Today we are going to use our SOHCAHTOA and law of sines and cosines to solve real-world triangle problems. Number 1. In college, Kelvin has become the top math major. As he's waiting outside the building for his calculus test to begin, he observes that a flagpole is casting a shadow on the ground and decides to calculate how high the pole is. So let's first start off by drawing a picture. Here's my flagpole. Here's its shadow on the ground. And I'm going to turn this into a triangle. Because this is a flagpole, I know this is going to be a 90-degree angle because the flagpole stands straight up and down. Let's see what else we know about this. He measures the shadow on the ground to be 22 meters long. So the shadow, which is on the ground, is 22 meters. So that means 22 meters is down here. He Googles it on his smartphone, finds that the sun's angle of elevation is 38 degrees. So angle of elevation is this angle down here. It's how much it's elevated from the ground. And we're looking for how tall the pole is, which is its height. So this is our unknown, our x value that we're solving for. So because this is a right triangle, we can use SOHCAHTOA to solve for x. So this is my angle right here. Let's first label our sides. Our hypotenuse is always the longest side. It's opposite the right angle. This angle right here is 38 degrees. This is the one we're using. So the opposite side is opposite the 38 degrees. So this is opposite. Adjacent is the one next to it. This is adjacent. So I want to pick the trig function that is connecting 22, which is my adjacent, with x, which is my opposite. So I'm going to have opposite and adjacent. So I'm going to be using TOA, which is tangent of theta equals opposite over adjacent. So now we can plug in the numbers that we know. So our angle is 38 degrees. Our angle always goes after the trig function. Opposite is x, and adjacent is 22. So we're solving for x. We're trying to get x by itself. So what I'm going to do is get rid of this dividing by 22 by multiplying by 22 on both sides. That's going to cancel out my 22's, and so I'm left with 22 tangent of 38 degrees equals x. Once I have x by itself, I can now plug this into my calculator. So first make sure you are in degree mode, and then type in 22 tangent of 38 degrees. We get 17.188, 3 decimal points. And what is this measuring? This is measuring distance, how tall this pole is. So we do need units. Because our 22 is in meters, this is also going to be in meters. So this is my final answer, 17.188 meters. Okay, let's look at number 2. So, 10 years from now, Tavia has become the CEO of a manufacturing and shipping company. As one of her ships sails into the harbor, it sees a buoy at an angle of 15 degrees to the path of the ship. Her ship sails 1,300 meters further and finds that the buoy now makes an angle of 29. So let's start off by drawing a picture of this. So if this is her ship down here, we're going to call this A. At the very beginning, it's making an angle of 15 degrees to the buoy. So let's call this buoy B. And then after sailing 1,300 meters farther, which means it's continuing to sail, and it sails, let's say, here is 1,300 meters farther. Now it's making an angle of 29 degrees. So right here is 29 degrees. So we'll call this C. So this is currently what we know from this problem. Part A is asking us, how far is the ship from the buoy at the second sighting? So here's my ship now, here's the buoy, so we're solving for right here. Because this is opposite angle A, I'm going to call this side A. So we're looking for side A. What is side A? This is what we don't know. Okay, let's take a look at the information that we're currently given. So we know that this 29 degrees is outside of the triangle, but because of this 29 degrees, we can find this side, this angle C, because right now this is a straight line. A straight line is 180 degrees, so I can just do a 180 minus 29 to get to angle C. So angle C is 151 degrees. So whenever it's a straight line, I can do 180 minus 29 degrees. That gives me this angle right here. Now I have two angles, so how am I going to find my third angle? Add them up, subtract by 180. So this is to find angle B right now. We can do 180 minus our other two angles. And that gives us an angle of 14. So now we know all three angles inside of this. Let's look at our triangle and see if we have any pairs. So this is side A. It's across from angle A. This is angle B, so this side down here is B. And over here is C. So we do have a pair. We know angle B and side B. So from that, we can use our law of sines. This is part A. Sine of angle goes on top, side goes on the bottom. So B and B. And we're solving for little a, which is a side, so that goes down here. And we do know the angle A, which corresponds with side A, is 15 degrees. So now I'm just solving for A using law of sines. So I'm going to cross multiply. And then get A by itself. And so this is what I'm going to plug into my calculator. Don't forget parentheses after the 15. And I end up with A equals, so because this is a side, 3 decimal points, 799. And since it is measuring distance, my 1300 was in meters, and so this is also in meters. This is my distance from the ship to the buoy at the second sighting. Okay, so let's do part B now. What is the closest the ship is going to come to the buoy? So this is going to require us to make a second triangle. So on the same triangle right here, I'm going to make a second triangle, and it's going to be a right triangle because the closest the ship is going to come is going to be at a right angle. So this is the side that I'm looking for now, and let's label this Y, since it's going up and down. So we're looking for this. We know this 29 degrees right here, and we know the side A since we just solved for it. So because this is a right angle, we can use SOHCAHTOA. And we're looking for, if this is the angle we're using, Y is the opposite. And we know this length right here, side A, which is my hypotenuse. So I'm looking for the one that puts together opposite and hypotenuse. That's going to be sine. So now I have sine of my angle, which is 29 degrees, equals opposite over hypotenuse. My opposite is Y. My hypotenuse is what I just found, which is 1390.799. So now I'm just solving for Y by multiplying both sides. And so when I put that into my calculator, I end up with 1390.799 times sine of 29 degrees. And I get 674.273. And again, this is distance because it's how far from here to here. So it's going to be meters again. This is my answer for part B. Finally, part C is asking us, how far must the ship go from the second sighting point to this closest point of approach? So how far has the ship gone from point C now to, let's call this point D. Point D, so let's call this X. So now we're looking for the bottom part of this triangle, the purple triangle. Again, right triangle, we're going to use SOHCAHTOA, but this time my X value is my adjacent. So now I'm looking for my adjacent instead of my opposite. So with adjacent, now I'm going to use cosine instead of sine. So cosine of 29 degrees equals adjacent, which is X over, my hypotenuse is still the same thing, it's this length for A. We're going to do the exact same thing we just did, but now solving for the bottom side instead of the one on the right. So we're going to multiply both sides by 1390. And that's going to give us our X value. Plug it into our calculators. And we get X is equal to 1216.420. Again, meters, since we're measuring distance. Okay, so that was our longest problem today. Number 3 is going to be a quick one. So far we've used law of sines and SOHCAHTOA, so chances are number 3 is going to be on law of cosines. Okay, let's look at number 3. The United States has just launched 2 satellites. NASA sends its most talented astronaut, Jose, to observe the satellites. As Jose approaches the 2 satellites, he finds that one of them is 8 kilometers and the other is 11 kilometers from his. So if this is his ship right here, his satellite, this is Jose. Satellite 1 is 8 kilometers away. And satellite 2 is 11 kilometers away. The angle between the two is 120 degrees. And we're looking for how far apart the satellites are. So from satellite 1 to satellite 2, this is what we're looking for. So we'll call this X. Okay, so we have, it's not a right triangle, so it's not SOHCAHTOA. We know 2 sides and an included angle, so we're going to be using law of cosines to find this right here. Because we're looking for a side, we're going to use the equation for side, not for angle. So we have x squared equals the other 2 sides, so 8 squared plus 11 squared, minus 2 times those 2 sides again, so 8 and 11, and then cosine of the opposite angle, which is 120 degrees. And to get x by itself, we're just going to undo the squared with the square root. We're going to put all that into our calculator. And it gives us 16.52. We're going to round that to a 3. And because it is distance, we do have units. 8 and 11 are both measured in kilometers, so this is also going to be a kilometer. So our answer is 16.523 kilometers.